Guys, in this video, we will discuss about that how to solve a system of linear equation by using the Gauss-Seidel method. So first of all, we have to know that what is the criteria that how can we solve a system of linear equation by using Gauss-Seidel method. So see here that here I just in the next slide I just take one example, or there is a we construct a equation with three equations and three variables. So now if we consider this system of linear equation, then how can we solve it by using Gauss-Seidel method? So here I write the Gauss-Seidel method. The working formulas are like this, that is x1 k plus 1 is equal to 1 by a1 1 b1 minus a1 2 x2 k minus a1 3 x3 k. X2 k plus 1 is equal to, you can write 1 by a2 2 b2 minus a2 1 x1 k plus 1 minus a2 3 x3 k, and x3 k plus 1 is equal to 1 by a3 3 b3 minus a3 1 x1 k plus 1 minus a3 2 x2 k plus 1. So now that this is the working formula, but how can we proceed to solve a system of linear equation by using Gauss-Seidel method? So here, see here that we have to know one term here, that is the diagonally dominant. So what is diagonally dominant? Diagonally dominant, suppose if we consider this equation in the matrix form, that is Ax is equal to B, that is the matrix A contains the term A11, A12, A13, A21, A22, A23, A31, A32, A33. And the diagonal elements here are this one, that is A11, A22, A33. So now what is the concept of diagonally dominant? That is, the diagonally dominant concept is mod A11 is greater than mod A12 plus modulus A13. Modulus A22 is greater than modulus A21 plus modulus A23, and modulus A33 is greater than modulus A31 plus modulus A32. So see here that if this system of equation follow this condition, then we can say the system is diagonally dominant and we can solve it by Gauss-Seidel method. So here when we implement the working formula, we assume that this equation is diagonally dominant. But sometimes it may be happen that the given equation is of the form is not diagonally dominant. Then we have to make it diagonally dominant. And how can we solve it? Then I will explain it in the problem which I discuss here. So see that here I just consider one equation, one system of linear equation, that is x1 plus x2 plus 4x3 is equal to 9. 8x1 minus 3x2 plus 2x3 is equal to 20, and 4x1 plus 11x2 minus x3 is equal to 33. So you can see from here that if you follow this one, that is a11 is equal to 1, a12 1, and a13 is 4. So here we can say that modulus of 1, that is 1, is not greater than 1 plus 4. Similarly for this we get 3 is not greater than 8 plus 2, and 1, that is minus 1, modulus of minus 1, that is 1, is not greater than 4 plus 11 is equal to 15. So now we have to make it, diagonally dominant by changing the equation. So see here that if we can write, the system can be written as, you just see 8x1 minus 3x2 plus 2x3 is equal to 20, 4x1 plus 11x2 minus x3 is equal to 33, and x1 plus x2 plus 4x3 is equal to 9. So now see here that here what is the term a11? That is, here we can say that 8 is greater than modulus 3 plus modulus 2. That means 8 is greater than 3 plus 2 is equal to 5. 11, that is modulus 11 is also is modulus 4 plus modulus 1. That is 11 is greater than 5, and also 4 is greater than 1 plus 1 is equal to 2. So now we can say that this system is diagonally dominant, and we can solve it by Gauss Seidel iteration method. Gauss Seidel iteration method. So now how can we write it in the, and this is an iterative formula, so we have to find it. So now let us check that how can we solve it. So now the working formula for this equation, it will be that if you following this one, that is x1 k plus 1. So I just write it the equation here again. 8x1 minus 3x2 plus 2x3 is equal to 20. 4x1 plus 11x2 minus x3 is equal to 33, and x1 plus x2 plus 4x3 is equal to 9. So the working formula here we can write it by like this way, that x1 k plus 1 is equal to 1 by 8 20 minus 20 plus 3x2k minus 2x3k. x2k plus 1 is equal to 1 by 11. 33 minus 4x1 k plus 1 my plus x3k, and x3k plus 1 is equal to 1 by 4. 9 minus x1 k plus 1 minus x2 k plus 1. So now see that here we will start from k is equal to 0, 1, 2, 3 and so on. And when something is not given, so we will take initially x0, y0 is equal to z0 is equal to 0. Okay. So now here in this equation, if we put k is equal to 0, so what we get from here? That is, we will get from here, that is x1 of 1 is equal to 1 by 8, 20 plus 3 x2 0 minus 2x3 0. So sorry, here we will take x1, this is x2 0 and this is x3 0. So this is 0, so we will get this is 2.5. Similarly, now we have to find the x2 of 1, that is 1 by 11. 33 minus 4 into, if we put here k is equal to 0, x1 1, the value is 2.5, and x3 0, that is 0. So here if we calculate it, we will get the value, that is 2.0909. And if we put k is equal to 0 here, we will get x3 1 is equal to 1 by 4. 9 minus, that is 9 minus x1 of 1 minus x2 of 1. So what we get? 1 by 4. 9 minus x1 of 1, that is 2.5 minus 2.0909, and if we simplify, we will get the value is 1.1023. Okay, so now you have to just mark these values. That is, this is 2.5, this is 2.5, this is 2.0909, and this is 1.1023. So please note these values. And now next, here, see here that now if we put in the working formula here, that this is the main formula, that is x1 k plus 1 is equal to this one. So now here we have to put the value of k is equal to 1. So what do we get? That if we put here k is equal to 1, so we get x1 of 2, x2 of 2, and x3 of 2. So now if you put all this here, that in the equation, that is x1 2 is equal to 1 by 8, 20 plus 3x 1 minus 2x 1, x2 of 2 is equal to 1 by 11, 33 minus 4 into, okay, so now if we calculate it, we will get, that is 1 by 8, 20 plus 3 into 2.0909 minus 2 into 1.1023. So here from here we'll get 3.0085, and x2 of 2, 33 minus 4 into, so now here I'm just using direct the formula, using direct this formula, that is 4x1 of 1. So here what we get is 4 into 3.0085 plus 1.1023. So what we get from here? That is we will get 2.0062. And if we follow here x32, that is 1 by 4, 9 minus, this is now, that is 3.0085 minus 2.0062. So here we will get 0.9963. So now this is the second iteration, so just mark it, this value. And now if we follow the next one, that is the next part, that is x13, that is x13 is equal to, what can we write? That is 1 by 8, 20 plus 3x2k minus, that means here this is 2 minus 2x32. And if we simplify, you will get the value is 3.0032. Similarly, if we put x23, that is 1 by 11, 33 minus 4 into 3.0032 plus 0.9963, we will get the value is 1.9985, and x3 of 3 is equal to 1 by 4, 9 minus 1 into 3.0032, 3.02 minus 1.9985. By using the formula, we will get 0.995. And now see that, just mark this value, and if you follow, if you go another one, that is x14, you will get the value is 2.995, 2.995, x24, 2.0001, and x34, that is 1.0001. And now see that if you follow this one, that if you follow all the values, the iteration value, this is 2 point and this is 1.001, that the value reduces, that we can say that the solution is x1 is equal to 3, x2 is equal to 2, and x3 is equal to 1. So I hope that you can understand that how can we, but actually this is an iterative method, and you have to just follow for the second, third, and fourth. Here that is x1 2 is equal to, what we get, 1 by 8, 20 plus 3x2 2 minus 2x3 2, x2 2, is equal to 1 by 11, 33 minus 4x12 plus x32. X32 1 by 4, 9 minus x12 minus x22. Similarly, if you put here k is equal to 2, so similarly you have to just put the result and you have to put the values. So I hope now you understand that how can you find the solution of a system of linear equation by using Gauss-Seidel method. So thank you for watching the video.